Now, let's come to circuit element. There are two types of circuit elements found in electric circuit. These are passive elements and active elements. Active elements are those elements which are capable of generating energy, while passive elements are elements which are passive. Literally they can't generate energy. So active elements are examples of active elements are generators, batteries, or pumps, or operational amplifiers. So those of elements which are passives are resistor, capacitor, inductor. These are elements we found on circuit boards which are not capable of generating any amount of energy. So the most important active elements are voltage and current sources. Voltage sources and current sources. There are two types of active elements. These are voltage source and current source. Voltage source and current source. So the voltage source is depicted like this, just with polarities, positive and negative. When it is dependent, like this one, and for independent is like circular. So two kinds of sources. These are dependent and independent sources. Dependent and independent sources. An ideal dependent source is an active element that provides specific current or voltage that's completely independent of other circuit elements. So an active element that provides a specific current or a voltage. If it's a voltage source, it provides a voltage. If it's current source, it provides a current that is completely independent of other circuit elements. For example, let us see this one. Like most of the time, these are independent sources. These are independent sources. It's depicted, the independent ones are depicted circularly. When it's independent, it's depicted circularly, just circularly. When it's dependent, it is depicted quadrilaterally, like a rhombus structure. So if it's voltage source, it's come up with the polarities. If it's current source, an arrow showing the direction. This dependent. This is independent. For independent, and this one is independent current source. So let's see an example. This one. This circuit shows like here we have the independent voltage source. This voltage source is independent of the other branches or the other components in the circuits. It provides independently. It provides voltage needed, or the amount of voltage needed, just independent of the other circuit elements or branches. Whereas this one is the dependent current source. As you see, the dependent current source, this current is dependent on the I1. This source give us 0.2 of I1. 0.2 of I1. I1 is what? 5 ampere. So the amount this current source provide depends on this branch. The current on this branch. So that's why it's named a dependent source. If we see right here, another circuit, let us see another circuit. So these are the passive elements. It may be inductor, it may be resistor, or some capacitor. it's an independent source. These are passive elements. So this is depicted circularly. It is a voltage source, come up with polarities. So this is independent. This is independent. This one is dependent. So both are the voltage sources. This one is dependent. This one is independent. As you see, this voltage source is 0.6 I3 volt. So I3 volt. This voltage gives us 0.3 of I3 volt. The amount of voltage this source gives us depend on the current in this branch I3, which is 5 ampere. So this source is depend on the amount of current on this branch. So that's why it's called dependent source. So this one is independently, just provide 2 volt independently. So independent of other branches, whether the current on other branches changed or unchanged, the amount of this voltage is fixed. Best example for independent current and voltage sources are batteries and generators. Just independent voltage source. There are, an approximation for independent voltage source. Just an approximation for ideal independent voltage source, batteries and generators. An ideal dependent source is an active element. An ideal dependent source is an active element in which source quantity is controlled by other voltage or current. So an ideal dependent source is an active element. As I said, they are controlled by another voltage or current, as I showed you right here. So there are 4 possible types. There are voltage controlled voltage source, current controlled voltage source, voltage controlled current source, and current controlled current source. In this example, this one is current controlled. It's controlled by I1. So it is current controlled current source. This is current controlled current source, dependent source. While this one is a voltage source. Basically, it's a voltage source. It's controlled by I3, the current in this branch. So it is current controlled voltage source. It is current controlled voltage source. So now let us solve some practical problems. The first example says that the essential component of a toaster is an electrical element or a resistor that converts electrical energy to heat energy. How much current is drawn by a toaster with a resistance of 15 ohm? So we are given 15 ohm and 110 volt. So our givens are the resistance and the voltage. So the required is the current. Simply I is equal to V over R, which is 110 over 15. Just simple, very simple examples. So the second example is calculate the voltage, the conductance G and the power for the following figure. The figure is given by this circuit. This is the circuit. So there is an independent current source of 3 milliampere and 10 kilo ohm. So 3 milliampere, independent current source of 3 milliampere and 10 kilo ohm. So we are asked to calculate the voltage in the conductance G and the power for the figure. So V is equal to IR. Simply V is equal to V is given by IR. So I is in this case 3 milliampere. This source provides constant of 3 milliampere. So the voltage across this element. Simply to calculate the voltage across this element, we need to know the current flowing through this. So the current is simply the amount which is provided by this current source, which is 3 milliampere, and the voltage across this is calculated by multiplying the current times the resistor. So the current is 3 milliampere, the resistance is 10 kilo ohm. So multiplying this will give us 30 volt. The conductance is simply the reverse of the resistance, the inverse of the resistance, which is given by I over R, I over 10 times 10 raised to 3 ohm, kilo ohm, which is 10 raised to minus 4 Siemens. It's given by Siemens. The power dissipated on this resistor is given by the current flowing through the resistor times the resistance, the constant, the resistance of the element. The resistance of the element is given by 10 kilo ohm, simply 10 kilo ohm, I square R is the formula for power. So multiplying this would give us 9 times 10 raised to minus 2 watt.